Okay, this is for you, Griffin. Maybe you'll watch this like 3 years from now.
We're probably like 4 weeks behind.
Facts and logic. Okay, there's some facts and logic for you. We're covering 7a. So we modified the integral to look like this. So now it reads, that's in this form. So u prime sine of u. So, okay, so then this is going to be, now this is maybe it's a little tricky. It's going to be, this here would become, the integral itself would be negative cosine of u, but there's also a negative out there. So those are going to cancel each other, and you're going to get positive cosine of u.
Very nifty.
That's nifty, right?
Nifty.
So, by the way, you guys remember that function? It's famous. Or the sine one's more famous. This is the more famous version. I'll give 100% extra credit on the next quiz to anyone who remembers the name of it. Anyone?
Let's do something.
The
420.
sine over x.
Is it a sinusoidal function?
Well, this was really close, actually.
It's like the,
Is it a
it also
it's
starts
a-
with an S. It starts with a T and an S.
How can a word start with a T and an
There's
S?
2 words.
Okay. Okay.
Is that the same one?
Sigma.
The answer was the topologist sine curve.
Oh.
Alyssa, you were close. That was close.
So they should give her like
Extra credit
Yeah,
and
a
the-
little bit.
It's an interesting function because if you pick any positive number, no matter how small of a number you pick, so you pick, okay, I pick an x value of 0.000001. This graph crosses the x-axis an infinite number of times between 0 and that number. It gets crunchy. It's a crunchy. When it gets towards the x-axis, it goes
It's like the one
NVMs.
you showed us
NVMs.
graph.
Yeah, I've showed it to you before. On the old Desmos. Okay. Let's look at B.
B.
What makes these challenging is that, you know, if it was a whole problem of, I don't know why I erased that, but if it was a whole page of like, oh, these all have the form u prime times cosine of u, and you just had to convert them into sine of u, well, that would not be challenging at all, would it? That'd be extremely easy. So that's why these are not easy. Calculus isn't easy. B is not in that form, okay? It's also not, I'll give you a hint, it's not this form either.
Oh, you from-
So what form is it? There's not that many forms that we study, but part of the challenge is, one, keeping everything straight, but two, figuring out what form am I looking at. So this one, I'll give you a hint on this one for B. It's of this form.
Is it like tangent line times u to the 10?
Yes.
So chain.
They're all chain rule questions at their heart.
At their hearts. In their soul.
Well, do you see these are all the chain rule.
Yeah.
There's different applications of it. So the chain rule tells us that, I'll give you here a quick example. The chain rule tells us that the derivative of sine of x to the 5th power would be 5 times the sine of x to the 4th power times the cosine of x. That's the chain rule for derivatives. So the integrals just go in reverse. So now that I told you that, if you believe me, does one choose to believe something, Mr. Rafe? Tell me that,
Calculus?
sir.
Yes.
Callie Jo knows. She knows, right, Callie Jo? She knows. What am I gonna write? What number am I gonna put right here?
1/2, negative 1/2.
Negative 1/2. So now, do you see how it's that form?
Yes.
It is this form. So the u, in this case, is sine of x, and the u prime is cosine of x. Yeah, bruh?
Yeah.
Yeah, bruh.
Yeah.
Is that a reusable Ziploc bag?
Yeah,
That's a good flex.
they're so cool. I have like 10 of them.
That's
I have
easy.
an issue.
Now I feel ashamed about this.
But Ziploc makes them sell.
Yes.
No. I put soup in.
I imagine after you wash it a few times, I guess you could.
I
Those
think-
thick ones, those freezer bags, I think you get a lot of use out of those.
I mean, I have a specific pancake one that I
So, what's the answer then? Let's look at that. So there's two questions here. One's harder than I guess maybe equally easy. Do you see how that is that form?
Uh-huh.
Two, do you know how to then apply?
Yes.
You do. Good.
Thank you.
We'll see.
So it'd be u
One half.
to the positive 1/2 divided by positive 1/2. Which of course, this could be much more easily rotated, like 2 times the square root of sine of x. That's a pretty nice function. Right, Jesse?
That's what I got.
Yeah.
It's very beautiful.
What, Lillian?
Jesse, do you ever listen to Jesse Girl?
Yes, you do.
By,
Yeah.
yeah. I love that. It's a great song.
Okay. So these are all kind of like that. Some might stump you. Some might not stump you. But you're just looking for these forms. Now, of course, they're with hand in hand with this form is things like, just for example, u prime times, this is one example. There's a whole bunch of examples here. What would this one turn into? Tangent of u. So any function we know the derivative of, there's an antiderivative that, just look out for that u prime. This is honestly, this is probably one of the hardest ones to pick out just because it often involves like this, manipulating it slightly to get it to look like this. This one also can be kind of tough to see. Let's just check one verbally real quick. What form do you think D as in daffodil, 70?
U prime over U.
What up?
So, the, integral of sine of x is negative cosine of x, so shouldn't we have put a negative sign on the outside of the thing? Because the u prime has to be negative?
It has to
This
be.
problem?
Yes.
This one? Well, the
Because u prime.
derivative
am I
of sine is
thinking-
positive.
Just
cosine.
kidding, yeah. Sorry.
It's okay. Let's do one definite integral and then we'll just have a work day. We have 30 minutes, 25 minutes. Okay, let's pick one from number 9. So, I don't know.
C.
Might as well just we can just do the first one. They're all kind of the same, but.
Can you just do one with the weird radians so we can see it?
I guess we can do A and B. B has a fascinating result. It's actually one of the most fundamental results in all of calculus. So we'll definitely gotta go over that. Let's do A first. A is a little bit more just straightforward. It says go from 0 to 1 of this function x times the sine of
Pi x squared.
pi x squared dx. What is that? It's a number. It's well,
Not quite.
this is a nougat.
That's on this side.
It's like, you ever seen, what's that movie with the Australian guy? And he goes, "That's not a knife. That's
No,
a
Crocodile Dundee.
Yeah.
Crocodile Dundee. That's not a nougat. That's a nougat." That's how it works.
That's not a knife.
That's not a knife. The whole scene makes no sense. It's like you can still stab someone with a small knife. He's like, you guys ever seen this movie, Crocodile Dundee?
Yeah,
No.
No, let's watch it.
it's a great movie.
This mugger tries to mug him. He's like from the Australian outback. This mugger tries to mug him, and he goes, "That's not a knife," and he pulls out his big Crocodile Dundee knife. It's like the long blade. That's
It's
a
a
knife.
close down.
Flawless Australian accent, by the way. That was perfect.
You're
What's it like to be in the presence of a brilliant actor? Actor.
Indeed.
Who needs to live right there? I hope this one's kind of obvious. This is a U prime sine of U form. There needs to be a 2 pi here. You understand?
Yep.
That means you got to put a 1 over 2 pi way out here. We feel okay? Any questions?
Feelies engaged.
And the key there is pi is just a number. So don't get confused. People do get confused. They go, "Oh, I got to use like the product rule," or I don't know. That's a number just like 5 or 3. So it behaves as such. So you got the 1 over 2 pi out here. And then you got, so what's going to be the antiderivative of this, of u prime sine of u? Negative cosine.
Pi to x squared.
You feel okay about that?
Oh.
The integral of u prime, so u prime sine of u is going to turn into negative cosine of u. You okay? Ready? Finish it? So, then you go, okay, well, plug in the 1. Be really careful. Plug in the 0. Does that make sense?
Mhm.
So what's the cosine of pi? Negative 1. So this is negative 1, also known as positive 1. This is, what's cosine of 0? So minus negative 1. Look at that, you get a beautiful number there, you get a beautiful answer. The reciprocal of pi is the answer. Nice. Okay, let's just really quickly go over B. Just want there to be no confusion there. B is a quick one because you're just like, oh, you're just asking me this really simple integral. But I don't know, maybe you guys can tell me, why do you think I put this on here? Why would I want you to do this really simple one?
Because it gives you.
Yeah, what makes it so fundamental? Visually.
It's the, it's half of
Yeah,
the,
it's half the unit circle.
what's it called?
That's one way to think about it. Unit circle, yeah, it's this going from 0 to pi talks about taking all the sign values from here to here. By the way, all the sign values from here to here are what? They're all positive. So if you graph the sine function, this is actually the reason is, if I graph the sine function, 0, where's pi?
Where it goes to 0 again.
That guy. So this question is actually asking you, hey, we've been looking at these Humpty Dumptys for a couple years now. How much area is trapped under that Humpty Dumpty? Under one Humpty? What's up?
What is that called? It's like it's each, oh my God.
Humpty Dumpty?
No, when it's a repeated thing over and over again, what is one called?
One period?
Yes, period, thank you.
Oh,
For
there you
God's sake, I couldn't remember what it's called.
Yeah, this is a periodic
Period.
function. Yeah, this is a full period of the function. Because if you go all the way around, then you just repeat.
Yes.
But this is one Humpty Dumpty. How much area is in there? Well, let's see. By the way, how tall is this line? Yeah, the height is 1.
And it's an ellipse.
It's not an ellipse. It's its own thing. This is a shape that.
That
Maybe there is some.
definition.
We almost
I mean,
went there.
if there is a
Almost went
short name
there.
for it, then I don't know it. But one little hump of a sine function. Watch this. What's the antiderivative of sine of x? So negative cosine of x. Evaluate from 0 to pi. Okay, plug in pi. So it's -1, right?
This is.
Plug in 0,
You get 1.
and look at that.
Isn't that so cool? Wow,
The answer is just 2. That's pretty amazing.
that's amazing.
So there you go.
Okay.
Now what happens is you take that guy. Now what happened here? Well, there's a few things happening here. Is you transform that function. You can shrinky dinky, maybe horizontally. You can stretch it. You can shrink it and stretch it. That'll affect how big this area is. So what you're going to find a lot of the time is they love putting pies or multiples of pi or fractions of pi inside there. That'll modify the area. Okay, you guys work on your assignment.
That's